Good question. How can you know? You can check on Moodle.
Oh.
Yeah. The next lesson is practical problems, isn't it? Yeah. Yeah. I'm pretty sure of it, anyways. Yeah. So, listen. So, this last section on sequence and series is called practical problems. So, in this section, there isn't any new formulas. Okay, it's really just about using the formulas that we have to solve practical problems. So, I'll do some examples, but it's not like there's one way to do all of these. Okay, so we'll start off with something like there's a build. Think about an example from an exam question, maybe something like. Okay. So here you're building a bridge, and the way it works is, let's say to build the first, let's say the first meter, let's say it takes, here they are, 1 day. No, not quite 6. And then to build the next meter, maybe this one takes longer than this one, although that's not realistic. I think it should be getting quicker. Yeah, anyways, it doesn't really matter if it's realistic. So this one takes 2 days. So in total, it's taken 3 days to build these two here. And then this 1 meter, this will take longer to build, 3 days to build this one. Maybe, maybe what's happening is maybe the ground is very bad in the middle. So as you move further along, it's more and more difficult to build the extra part of the bridge. So then the next one, let's say that takes 4 days, and so on. So we'll put the total distance of the bridge at, we'll just make it 100 meters, for example. And we want to know how long will it take to build this bridge. So basically, for these practical problems, you have to realize what type of problem this is. So is this AP or GP? Which type would this be? It's an AP, yeah. If I want to know how many days it takes to build, it'll be 1 plus 2 plus 3 plus ... Now actually you know how many terms there are. How many terms are there? It's 100 terms. Because this 1 meter is like U1, and this is like U2, this is U3, and this is U4. So in total there's 100. So now this is just a problem with the formula for Sn, which you know, it's n over 2, 2a, what's the a here? 1, so 2a, plus n minus 1, and d is 1 also. So this is 5,050 days then. Yeah, that's not realistic at all. So I'll give you another one to try. That's a bit more realistic. So we'll leave that one and give you a better one than that. So more realistic is when you're building like something like a skyscraper. So as you move further up, it takes longer to build each floor. Okay, so let's say the first floor takes 20 days to build, and then maybe the next floor takes 18 days to build. Oh, sorry, I said it takes longer, didn't I? 22 days to build the next floor. No, longer or shorter? What do we think? Should it be longer or shorter for the next floor? I think shorter. I think it should be getting easier as you go up, because the most difficult one is the first one. Yeah, so we'll say 18 days for the next one, and then 16 days for the next one then as we move up. And let's say in total there are 10 floors. So I'll give you two questions to try. What floor is being worked on the, let's say, 60th day? So the first part is, what floor are you working on after 60 days? And then part B is, how long until it's done, it's completed. So, just to give you a little bit of a hint, this problem is a UN problem, and because this is how long, you want to add all the days together. So this one is an SN type of problem. So I'll let you try it first, and then I'll do it. So just remember, there are 10 floors we want to build in total. So there's going to be 10 floors. Okay. The part A was what floor is being worked on the 60th day, and part B is how long until it's done, the building's done.
How many floors were there again in total?
10. But you only need that for part B. Okay. We got the first part? What's the answer for the first part? What's the answer for the first part? Yeah, let's have a look. Yeah, do we have the first part? I know some people have it. So, let's look at the first part. So, it's GP, the A is 20, and the D is minus 2. And we want to know what's being worked on the 60th day.
GP, right?
Oh, sorry, I meant to say AP, sorry. It's AP, and the D is minus 2. Are we listening? Listen? Yeah. So I believe I lied to you. I'm sorry. It's not UN, is it? It's SN. It's SN. I'm sorry. If it didn't work, you only had one other thing to try. So it's not like.
What we just do?
I know. See, well, that's your first mistake. Yeah. See, you shouldn't be doing that.
So if we fail the exam, we should have.
You should never trust me. You'll learn this in time. Right. Okay. So SN. We want the total to be 60. Okay. So we have n over 2, and we don't know the n. This is 1, this is 2, this is 3, this is 4 for n. Yeah, n over 2. 2a plus n minus 1 times d. We want to know what's the n that makes this 60. So for example, if I said the answer was 20, what's the n that adds up to 20? It's just 1. And if I have 38 days, what will we have? It's 2. Yeah. So we want to know how many floors to make 60 days. In other words, we're trying to figure out when do we stop to get to 60 days of work. Okay. Right, so I don't think this is too bad to solve. This will be n This will be 40 minus 2n plus 2 equals 120. N times 42 minus 2n equals 120. Minus 2n squared plus 42n equals 120. 2n squared minus 42n plus 120 equals 0. And this is just a quadratic. I think the answer will be ugly, which is okay. So we get two answers. N equals 17.6 or n equals 3.4. So this is interesting. Which answer do we take? Yeah, but why not the 17.6? Because, we stop at 10 floors. Remember I said that? So here we know that the n should be less than or equal to 10. So this value is too big. So what's the answer? Do I round it down to 3 or do I round it up to 4? Yeah.
3.
Yeah. This is where we have to be very careful with the language. So what we have is, it's like, even if this was 3.8, I still would round it. Okay, yeah. Let me draw. Right, so this is n equals 1, yes? This is n equals 2. This is n equals 3. This one's n equals 4. So if you're at 3.4, that means you've completed 1, 2, 3. So you must be working on, but not finished, n equals 4. So what's the answer?
4.
No, 3. Because this is G. 1, 2, 3. Yes. No, ground.
But you didn't say that.
No, I didn't say this, and in the exam they didn't say this either. So this is just to show you that you need to be careful here. So the answer is actually 3, the third floor. Yeah. So please be careful about that. If you get a question with a building, just remember it starts at G. Okay. Yeah.
If it was, for example, like only 2 floors, and it was like 3.4, do we say if it's 2?
Well, it can't be because it's gotten too big then. I'll give you another one here. Yeah. Oh, sorry, there's the B part. How long until it's finished? Yeah. So for the B part, that's just adding, calculating S10, isn't it? So that's n over 2, 2a, what was a, 20, was it? Plus n minus 1, and what was the d? Minus 2. Okay, so what's that? That's 10 times 40 minus 18, isn't it? Is that 220 days? Oh, sorry, this is a 5. 110. 110 days? Yeah. No. Yes. Okay. Okay, let me give you another one now. Can I scroll down? Did you write anything down? How were you? Too much focus. Not enough writing. Yes. For the B part? The A part, yeah. Which part? The very end or the whole thing?
The very end.
The very end, yeah. Like this, literally this part?
Yeah.
Correct. Go from 4 to 3. Yeah. So in Ireland, and I think in the UK as well, when we count floors, the first floor, n equals 1, is actually called G. Is it everywhere? No,
It's just an island. It's everywhere.
is it? I thought. So is it only America that's different then? Huh?
We could different methods.
No. They go first, second, third.
No, we
And
don't.
these.
I've been to America. They do ground floors.
So if you go to an elevator in a state, it will look like this: G1, 2,
Yeah.
and not 1, 2, 3.
And minus 1.
I don't believe you.
I've lived there.
It's 1, 2, 3 or G?
We know
It's 1, 2, 3. Okay.
Don't believe me.
How do you believe you?
No, G is the. Okay, so then what's the problem then? It's okay. All right. Continue now.
But my question is, even if it's 3.4, what does the ground floor have to do anything? We just rounded it down, right?
No, watch, listen. If the question said, what floor are they working on? The answer is the third floor. Yes? If the question said, what level are they working on? The answer is the fourth level. Okay, so the language is important here for this.
If you go just a bit up, because we didn't finish.
No, I need to go on. You can just get it from the video. Yeah. All right. Now let me give you another one to try. Let's say you have an arithmetic progression, and the first, the second, and the sixth term are geometric progression. And the first term is, that's a U1 by the way, the first term is a 2. So, you can write that down, but just to explain the idea, if I just go to the side for one moment. Let's say I have this arithmetic progression here. Let's keep it simple. We'll say 2, 4, 6, 8, 10, and 12. This is AP. Yeah? Now, if I pull out U1, U2, and U4, they are 2, 4, and 8. Is this arithmetic? No, this in fact is geometric. So it's like you pull out 3 terms which will be geometric from the arithmetic. So in this one here, I tell you U is arithmetic, but U1, U2, and U6 make a geometric sequence. And the first term is 2. So we want to find A and D. Now I'll do this one, and you can just make notes carefully. Don't focus too much, make notes carefully, okay? So, we know the first term is 2, so that means A equals 2, so that's fine. We know that the second term, we don't know it, so we'll just write A plus D. And then the sixth term, that's A plus 5D. And let me just remove that 2, I'll just write A. But I'll write here beside that, but we know A is 2. Okay? So this is U1, U2, U6. But these 3 are also geometric. So when I take this and divide it by this, what should I get? Or. If this is geometric, then when this divides by this, it should be OR. And this one, when it divides by this one, it's OR as well. So you can say A plus D over A equals A plus 5D over A plus D. But you know the A is 2. So we get 2 plus D over 2 equals 2 plus 5D over 2 plus D. Now we can solve this one for D. So we'll cross multiply. That goes there and that goes there. So now we have 2 plus D times 2 plus D equals 2 times 2 plus 5D. This one will be 4 plus 4d plus d squared equals 4 plus 10d. That's okay, isn't it? Yeah, so this will be a quadratic, won't it? Is that okay here? Yeah. Let's see what quadratic we get. I'll just have this d squared, so that's okay. 4d minus 10d minus 6d, and then the 4's cancel, equals 0. So this is d times d minus 6 equals 0. So we have two choices here, 0 or 6. So we take the 6 then, because if it's 0, it's not really a sequence, it's just the same number repeated. So we know that d equals 6, and we know what the a is. A equals 2. So let's test that this works. The first term will be 2. The next one? 8. Yeah, and the next one? 14, isn't it? We're at 6. 20, 26, 32. And I said the first, the second, and the sixth is geometric. Is 2, 8, and 32 geometric? Yeah, it is. 2, 8, and 32 is geometric with a equals 2 and or equal to 4 then. Okay. This is also another type of practical problem that they like in the exam. Although I know it's not really practical, it's just a word-based problem, but they like this one in the exam as well. So if you can write this one down as well, please. You don't need to do that check at the end. I just did that to show it that it works to you. Because you should not believe me in any way unless I show it to you. So if you can write this down. Yes. That's not really the question, that's just me writing stuff. I said the first, second, and sixth terms are geometric from an arithmetic sequence. Find A and D, that's the question. And this is what you're told.
Geometric from arithmetic.
That's the idea. I pulled out terms from an arithmetic to make it geometric. Okay, did you write this one down?
Can I see the proof, like the one you wrote? I know you said not to write it, but...
Can you see the what?
The things you wrote, like the checking, yeah.
Okay.
Yeah.
No, you can get it from the... What? Okay, fine. Hang on, maybe I can zoom out more. Okay. He's sick, so okay. But not all the way. Yeah, okay, fine. It's okay. Okay. You got that? Yeah? Okay. Let's continue down. Okay, can I scroll down? Okay. Right, so the next one now. So in this one, a ball is dropped and it bounces, and of course each time it bounces it doesn't bounce as high. So what happens is the ball is dropped and it'll fall down, it'll hit the ground, it'll bounce back up, but it won't bounce as high. And then it falls down, bounces and comes back up, and it continues like this. So for the first bounce, so the first one, we'll say, let's see. We'll say we'll drop it at about 50 centimeters. So we'll say this is the height that it's dropped at, okay? It's dropped at 50 centimeters, so it falls down, it comes back up. And then the second time it comes back up, it doesn't bounce as high. We'll say it bounces, let's see, 0.4 meters. Okay. And then next time it bounces, it's 0.32 meters, etc. So is this arithmetic or geometric? It's not arithmetic because the difference here is minus 0.1 and the difference here is minus 0.08. So it's not arithmetic, it's geometric. What is it being multiplied by each time? You can check it on your calculator, but each time it's being multiplied by what is it? No? 0.8, yeah. You typed it in upside down. 0.8. Okay. So I want to know how far does the ball travel in total? Okay, because it's moving up and down, up and down, up and down, and it's going to do this forever, because each time it bounces it only gets a little higher. Now I know in real life it will eventually stop, but in our example it just continues bouncing, it's just getting shorter and shorter each time. I want to know the total distance travelled by the ball. So to give you a little hint, and you can believe me this time, this is an S infinity type of problem. Okay, try this for a minute. We'll see who gets it. Try it. Give it to me in a decimal form, of course. We'll see. And it's not. Yeah? That's literally the exact thing he asked me 10 seconds ago, isn't it? Didn't you ask me if it was 2.5? It's not, I'm afraid. Now I know why you got 2.5. Because you forgot what the ball is doing exactly. You need to visualize it. Don't forget Juliana and the other people who got 2.5. Don't forget, when the ball goes down, it bounces back up as well, the same distance. Your answer is too small. You said 5? Huh? 2.5 is too small, yeah, because there's an up and a down. It's not. It's not 2.5, and it's not 5. Alright, let's have a look at this. Any other answers except 2.5 and 5? In other words, does anyone have the right answer? 8? No. No. 10. Because? Just because. Like, whatever. Right, okay, let's have a look at this. So the people who got 2.5, I know why you got 2.5. And the people who got 5, I know why you got 5. And when you see how it's done, you'll realise the mistake that you made. So, what's happening is the ball is dropped from 0.5 meters. It comes down and goes up to 0.4. It comes down and goes up to 0. What was the next one? 0.32. So if you just add these all together, that's wrong because it goes up and it comes back down. But if you multiply your answer by 2, that's also wrong. Why?
Because you're multiplying the
No. No.
You need to multiply each individual.
No. That's right. The first one hasn't gotten up. So what this here is 0.5 plus 0.4 plus 0.4 plus 0.32 plus 0.32 etc. Now what's nice about the numbers here is that they're all in pairs. So you can save a lot of effort by just taking a 2 out and writing the number once, etc. Now this here is GP, it's infinite. What's the formula? A, which is 0.4 in this sum, over 1 minus or, which is still 0.8. So this comes in at 4.5 meters. Now the people who got 5 meters as the answer, you realize what you did was you added this in that wasn't there. So if you just took this away from your answer, if you did 5 meters minus 0.5 meters, because you shouldn't include this, then you would have the right answer. When this question came up in the exam about, 4 years ago, only one person got the right answer for this one. Only one. A lot of people said 5 meters is the answer, and a lot of people said 2.5 meters. But nobody, except for one, realized that you don't count the first one because it's dropped from a height. And about half the people realize there is an up and a down as well. Okay, let's have a look at another one. Okay. Can I scroll down? Now you realise when I write it down there's not a lot there. The difficulty was in understanding it. I mean, there's only 3 lines there. Okay, can I scroll down? Yeah? Okay. So the next one I'll let you try. So, we'll kind of go for an economics type of one. So somebody spends €5. So what happens is, they go in and they buy a sandwich or whatever, and then the person who gets the €5, they don't spend all the €5 again. So if this was the shopkeeper, or the restaurant owner, they'll spend €4.50, but then 10% of it they'll put into the bank, into savings. So they'll save 10% of it, but they'll re-spend, I suppose you could say, the money that they get. So you go in, you spend €5, get a sandwich, and then the restaurant owner, he will spend most of this money maybe buying more food or whatever. But some of the money gets put into the bank. So it's like this money is gone. It's not to be respent. It's put away for savings. So maybe this guy, he then takes his €4.50 and, he buys a coffee and a cake somewhere. And the same thing happens again. Some of the money gets spent and some of the money gets saved. And it's again, we'll keep it at 10%. So 10% is 45 cents, isn't it? Yeah. So this time 45 cents gets saved, so it's like it's gone. And then spent will be €4.05. So you have this idea in economics that when I spend money, someone else will re-spend it and someone else will re-spend it. So it keeps making more sales, more activity. Okay? It's not like when I spent money in a shop, that money is now gone. That money is someone else's money. And they'll spend it. And it's still not gone. They'll re-spend it and so on. So you have this kind of like a cycle effect. I don't know if it's not. You don't need to know this for the question, but if you studied economics before, you might have heard of this. So what I want to know is my €5. When I first spent it, how much extra spending was made from it? So when I spent €5, this made how much extra spending in the country? Okay. So in other words, you want to add up all of these together. And each time it's 10%. So the first one is $4.50. That's extra spending from my first time I spent. What's the next one? 4.05. Now, can anybody see what the OR is? Well, you can use it on your calculator.
Minus 45.
No, the OR, it's GP. What is it? 0.9. And this will continue forever until there's nothing left. So I want you to calculate how much that is. It's much shorter than the last question. Basically add all of these extra spendings up. So make it a plus here. Okay, so here, what do we get? It'd be 4.50 over 1 minus 0.9, so that's 45. So think about what that's saying. That's saying when I spend €5, that means 45 more euros will be spent. What's wrong? You don't see what? I spent €5. So I spend €5. I buy your phone for you for €5, let's say. Okay. So what are you going to do with that €5? Will you eat it? No. You will spend it. So maybe you'll buy something from him. Now maybe you'll spend all the €5. But if it was something bigger, like €5,000, then some of it you will save and some of it you will spend. So let's say I spend €5, I get your phone, then you spend €4.50. You keep 50 cents to him. Again, he has money now, so he'll spend it, he'll buy something from him. He'll buy something for €4.05, and he'll keep 45 cents in the bank. And this will keep moving along. So in total, my first €5 I spent will show up as €45 of sales. You know, if you add up how many sales took place in this classroom, you spent $4.50, then he spent $4.05, then he spent, and so on and so on. So even though it's only one €5 note, it gets spent and looks like it's spent in total €45 in total is spent. Yeah. Now I don't know, has anybody studied economics before? Yeah. So this is called multiplier effect. It's when a little bit of spending leads to more spending. No? Just one economics student? And have you done this before? No? Not this. You studied it?
Yeah.
And do you know about this multiplier effect? Yeah, you've heard of it before. Yeah. Well, like I said, you don't need to know about it, but it just goes to show that you might be surprised by the results. You know that one €5 note can make 45 euro sets. So this is why when people are spending even a little bit less, then this is why it can have a huge effect on things, because all of a sudden there's so much less spending. Yeah. Let's do another one now. We'll do like a Google type of one. Okay. Can you wake the two sleepy heads up back there? Somebody who's beside them, sleepy heads, wakey wakey. Thank you. Right. So we'll do a Google type of result. So when you have Google search results, so let's just imagine we have our search results on a page, 1, 2, and I think there's 10 results per page, but nobody goes to page 2, and we all know that. Okay, so page 1. The number of clicks, depending on your position, is geometric. So for example, if 100 people click the first one, then I know that it'll be much less, of course, for the next one, that it reduces each time. but the way it reduces is geometric. Okay, so I think, let me just double check here what I had. Yeah, it decreases, we'll say roughly by about a quarter. So for example, if 100 people click the first one, then 75 people will click the next one. So each time it's being reduced by 25%. So the next one would be about 56, roughly. About 56 clicks for the next one. So this is actually, this is really what happens with your search results. Each time, the further down the page you are, you multiply by 0.75. So it's a geometric. We'll say about 0.75, roughly. Geometric. Decreases like this. So let's say in total for the 10 links, let's say, I don't know, there's like 10,000 clicks. If I tell you 10,000 people click the 10 links here, you can tell me how many people click the first link. That's what I want you to try and do. So I want to know how many people click the first link. If the total was 10,000, and you also know the links reduced like this by 25%. Now try it. Try it for a minute. See what you can get. And I'll give you a little bit of a help here. I recommend calling the first term A, so then the next one would be A or, and the next one would be A or squared. Okay, so this should get you going. Yeah? Any answers? What'd you get? I don't know if you've done something where it's the wrong way around. I think it's a little too big. What'd you get?
250.
That sounds a little too small now. It's like you missed a zero. Okay, so let's have a look at this now. S10, because if you add up these 10, what should that equal? 10,000. Okay, alright, I didn't say you didn't. Okay, so S10 is 10 over 2, 2a plus, no, it is not. I've used the GP one, sorry. It's a 1 minus or power 10 over 1 minus r, which is 0.75. And that should equal 10,000. So this should give you the A easily if you just type this in on your calculator. What was this number, by the way? Was it about 4? Is this about 4? I think it is. Yeah, this is about 4, isn't it? It's like 4A equals 10,000. Let's double check that. Oh, it's not quite 4, it's nearly 4, is it? Can you give me the exact number? 3.77. 3.77? A equals 10,000. So A is... Okay. 2,653 about, roughly. In the exam, if you got any answer, if you got the first 3 significant figures right, you'll get it. Yeah, no, but hang on, listen. For the exam, they'll just care that you get 3 significant figures right. So the fact that you get 265 is good enough. Yeah. Because it'll depend on how much you round here. I maybe rounded too much there. Okay. Right, so, question? Yes? This one here, it was how many people clicked the first link. So the question was basically find A. I want to know how many people clicked the first link. And I tell you, 10,000 people clicked links 1 to 10. And I tell you that each time you move down your Google list, you have only 75% clicks of the previous one. So each time you move down, you get less clicks. You only get 75% the previous. Yeah, so the question was find A. How many people clicked the first one? So 2,650 people clicked the first one. This means when you look at a page of 10 Google results, that basically you're saying that 1/4 of people will click the first link, which is, maybe that's, I don't know if you thought it'd be more or less than that. Okay, also it makes you realize that if you move down 75%, then when you go back up, if you can, every time you increase by 1, you get like about 25% more clicks. So there's really a big difference between your position on Google for how many clicks you get. Okay, now, for homework, yes, question? What's the question?
We get 2,650.
Yeah.
How come to 2,650?
3 significant figures. Yeah. Did you do this with Lorraine as well? Significant figures. Yeah. She used the same word, significant figures. Yeah. Okay. All right. So she uses the same word. Okay. Now for this homework, the questions are all practical. There's not like parts A, B, C. They're all like little stories. So if you can do all the questions on the page, you don't even know how many there are. There could only be 5 questions on the page. Now there's not 5 questions on the page, but there could have been. It's not even 10. When's our next class? Is it? Yeah, but when's our next class? Tomorrow? Yeah. So I know that's a lot to do, so you don't need to do them all 3 homeworks for tomorrow, but definitely should be finished by the tutorial on Thursday. And I have a funny feeling that the tutorial on Thursday will probably be mostly the practical problems. So it's important that you really try your best on those, because you get these in the exam. I think, just so you know, this question was an exam question. Okay. A final exam question. I know because I wrote that one. This one here was an exam question. This one here was an exam question. And this one here was an exam question. So, I mean, these are all exam questions. So you need to practice all of them, because, it's what you get in the exam. It's like this.
Can I ask
Yeah.
about
About what? Yeah. What about it?
we said the first one we don't count it, we don't count it like 2 because it's only about...
Yeah, we'll finish there, yeah.
Right?
Yeah.
So what kind of equation did you use? Did you use the same infinity equation?
Yeah, that one there I used was A over 1 minus R.
I know, but how come we didn't include 0.5? I mean, we know it's
Because I just narrowed in on all of these, because all of these are in pairs and I can take out the 2. But I can't do that with this one, so I kept it separate.
Alright.
Yeah?
Yeah. And these count as A, right? Because...
The A is whatever's first in the sum. Whatever's first. In the sum.
Okay, I get it.
Yeah. Yeah? Okay, I'll close this now.